Let's start with paper 7, and question number 1 in paper 7 says two charges, one is 5 nanocoulombs and another is minus 5 nanocoulombs, are placed 1 millimeter apart. Find the dipole moment. So here the charge is Q equals to 5 nanocoulombs 10 to the power minus 9, and separation, which is 2a. 2a itself is the separation, 1 into 10 to the power minus 3. Why minus 3? Because it's millimeter, so you have to convert it into meters, and the dipole moment P will be equals to 2a Q. Now what is 2a? 1 into 10 to the power minus 3, and what is the charge? 5 into 10 to the power minus 9. So this will give us 5 into 10 to the power minus 12 coulomb meter. So correct answer is option B for question number 1. Let's move to question number 2. So question number 2 says an electric dipole when held at 30 degree. So theta here is 30 degree given. With respect to a uniform electric field E is 10 to the power 4 Newton per coulomb. Experiences a torque. Torque is given by tau, which is 5 into 10 to the power minus 8, and unit is Newton meters. The dipole moment you have to find. So what's our relation for torque? Torque tau is equals to Pe sin theta, where P is the dipole moment, E is the electric field, and theta is the angle. So we have to find what? Our dipole moment. So P will be equals to torque tau upon E sin theta. Now what is torque? Torque here is given as 5 into 10 to the power minus 8 upon E. What is electric field? 10 to the power 4, and sine of 30. Sine of 30 is half. Let's simplify it. Okay. So this 2 will go on the top. It will become 2 5s are 10 into 10 to the power minus 8 into 10 to the power minus 4. So this will become 10 into 10 to the power minus 11. So correct answer is 10 into 10 to the power minus 11. Okay. Let me recheck because the option is not there. So theta is 30 degree. Correct. So 2 will go on the top, and minus 12 and 10 to the power minus 11. So 10 into 10 to the power minus 11 is the correct answer, coulomb meter. So correct answer for this is option D, none. Okay. Question number 2. Let's move to our next one. Question number 3. Electric field due to an electric dipole on its axial plane. Now this is a derivation, and you should know it is equals to 2πr upon r square minus a square whole square. Okay. So it is 1 by 4 pi epsilon naught. Okay. 2πr upon r square minus a square whole square. Clear it is? So option B is the correct answer for third one. Let's move to question number 4. Electric field on its equatorial plane. Now equatorial plane, be very careful. There is a negative sign in the dipole moment because the direction of dipole moment is opposite to the direction of electric field, net electric field. That's why we take a negative sign at the end. So minus P upon r square plus a square whole power 3 by 2. Great. Let's move to, they were direct questions. Question number 5. The torque experienced by an electric dipole when it is placed along the direction of electric field. When it is along means theta is 0 degree. And if theta is 0 degree, torque tau is Pe sin 0, and sin 0 is 0. So along means 0. Okay. Parallel. So 0 is the correct answer. Let's move to question number 6. An electric dipole consists of two opposite charges of magnitude this and, okay, so Q here is nothing but 4 into 10 to the power minus 5. Distance 2a. Be very careful. It's 2a, not a. The dipole is placed in an external field. E is equals to 4 into 10 to the power 5. The maximum torque. Now torque will be maximum only if tau is equals to Pe sin theta. We know that sine makes a very important role here. Okay. So it will be maximum if theta is 90 degree, right? So for theta being 90, it is maximum. So in direct way, they are saying that theta is 90 degree. Okay, in words. So torque tau will become P into E. What is P? P will be 2AQ into E. Now what is 2A? 2. Q, charge. Charge here is 4 into 10 to the power minus 5. And electric field is 4 into 10 to the power 5. So this will be 4 4s are 16. 16 2s are 32. Okay, and 10 to the power minus 5 and plus 5 cancels. So 32 Newton meters. That's our option A. Clear? Let's move to question number 7. The torque experienced by an electric dipole having dipole moment vector. Now dipole moment vector, electric dipole moment vector is P vector, which is equals to 2i minus 3j plus 4k, and placed in an electric field E, which is equals to minus 3i plus 4j minus 2k. Correct? So you are asked with the torque. So torque tau will be equals to P cross E, if you remember. So let's find the cross product of P and E. In case if you don't know how to find the cross product, focus. First of all, you have to make a determinant like this, okay, or two vertical lines like this. Right here I cap, j cap and k cap, okay. Now write the first vector which you have to multiply. In this case it is P. So 2 minus 3 and 4. These are the components of I, j, k. You can check here 2i minus 3j plus 4k. Now write the components of electric field, which is minus 3, 4 and minus 2. Correct? Now how to figure out that cross product? So P cross E or torque will be equals to, first write I cap. Ignore the row of I and column of I. So column is this one along the vertical direction and row is along the horizontal direction. So ignore the row and column of I. You left with 4 elements. Which one? Minus 3, 4, 4 and minus 2. Okay. So multiply, keep a bracket. Minus 3 into minus 2, which is 6 minus 4 4s are 16. Let me repeat, this into this minus this into this with these 4 elements. Correct? Okay. J is always negative. Now in case if you have done in maths what is determinants, you know that cofactor will give you here negative sign. In case if you don't know, you just remember, if you are a bio student, minus j cap. J is always negative, and if you ignore the particular column of j and row of j, you left with this into this minus these 4 elements. So let's use these 4 elements. It will be simply 2 into minus 4 and minus plus 12. Finally k cap plus k cap. K is again positive, and k cap again ignore the row and column of k. You left with these 4 elements here. So 4 2s are 8, minus plus, so minus will remain there, 9. So this will be equals to how much? You left with minus 10i minus 8j minus k cap. This is the torque. Okay. So minus 10 is there. Yes, option A and C. Minus 8, option A and minus. So correct answer is option A for question number 7. So this is the way we calculate torque in case vectors are given. In case vectors are not given, you can directly use P into E. Okay. If magnitudes are given. Again, let's see once again. The question is in form of vectors. The torque experienced by the electric dipole having dipole moment vector. So dipole moment vector again is given P is equals to. Try this, stop this video and try this yourself, okay? And you can verify the answer at the end. And in case if you have not understood, again, focus. So minus 2i plus 5j plus 3k. Let me repeat again. Make 2 vertical lines here, okay? Put here I, j and k. First vector is P. Sir, what if I put instead of P, E? Then things will give you wrong results. You will get extra negative, which is not correct. Okay. So keep P first. What are the components of P? 1, minus 2, 3. Minus 2, 5, 3. Correct. Now I cap into minus 6, minus 15, minus j into, ignore the row and column of j, and multiply 3 plus 6 and plus k cap into 5 minus 4. So what we left with? We left with 15 and 6 minus 21 I cap, 6 plus 3 9 minus 9 j cap and plus k cap. Is there any such option? Yes, option C is there. So correct answer for 8th one is option C. Let's move to question number 9. Question number 9 says the torque experienced by an electric dipole will be maximum if the angle between the electric dipole moment and electric field will be maximum. So theta will be 90 degree. We have discussed this in the previous question, because torque tau is equals to PE sine theta, and sine theta is 1 if maximum is when it is 1, right? So theta will be 90 degree. For theta being 90 degree, sine is maximum, right? So why our talk depends only on theta here? Not only on theta, keeping dipole moment and electric field fixed, it will depend on theta, right? Let's move to the 10th question, last question from this worksheet. So an electric dipole consists of two opposite charges of magnitude this and okay, so charge here is Q equals to 3 into 10 to the power minus 5 coulombs. Distance is 2a, which is equals to 1 meter. The dipole is placed in external field E, 4 into 10 to the power 8 Newton per coulomb. Find the maximum. So again they are saying maximum torque. Maximum torque means theta being 90 degree. Okay, theta being 90 degree. So torque tau is equals to PE sine theta, and its theta is 90 degrees, so it will be P into E. So it will be 2AQ into E. So let's substitute the values. What is 2A? 1 meter. Q is 3 into 10 to the power minus 5. Electric field E is 4 into 10 to the power 8. So 4 3s are 12 into 10 to the power 3 Newton meter. So 12 into 10 to the power plus 3 it is. And here it is given minus 3. So correct answer for this is plus 3. So option D, which is none. The correct answer is none. 10 to the power plus 3 it is. This was paper 7.